Hello guys, today we will learn about the capacitive contribution calculations using the specific capacities and current densities, which comes from the charge and discharge profiles at different C rates or current densities. Unlike the other peoples which uses the CV test to calculate the diffusion and capacitive contributions, today I will show you only capacitive contributions from the specific capacities. For example, you have a lithium-ion battery which you have calculated its specific capacity, or we can say charge discharge capacity at different current densities using the rate performance test. So for example, we consider these are the current densities which are known as J, and we got these specific capacities at these current densities. Now we want to calculate the capacitive contributions, because there is also capacitive behavior in battery but very small compared with the supercapacitor. So we can do it using very simple steps. First we need to get the 1 over square root of current density. Then we can plot a graph between this, and then we will get the intercept of this linear fitting, which will be known as capacitive contribution, and we can use that to calculate the capacitive percentage at specific current densities. So let's take this into the origin, because origin is more functional compared. Okay, this is the current density. Now we will calculate the scale 1 over square root of square root of which column? Or we can directly insert column this and then close the bracket. Let's see it works. Yeah, it worked. So now we got this 1 over square root of our current density. Then we can insert the value of specific capacities, copy and paste here. Okay, now we need to draw a graph between these. So let's make it x-axis. Okay. Then draw a simple scatter graph. Okay, we got it. Now we need to click here and do the linear fitting. Click on analysis, fitting, linear fit, and open dialog, and click OK. Okay, now we got the intercept, linear fitting, etc. So what is the value? We can see here. So here the intercept is 127.1. So this intercept 127.13 is the capacitive contribution, but not percentage at specific capacity. So now we can use this to calculate the capacitive contribution or capacitive behavior or percentage at specific capacity, like 0.1, 0.2, 0.3, 0.4, 0.5, and 0.6 in our case. You can use any current density. I am using this for tutorial. And you can simply equal to 100 multiplied by what is the Q contribution in 127.13 divided by capacity, specific capacity as this current density is 200. Then close the brackets and enter. Yeah, so this is the capacitive contribution. And let's continue for the other current densities. So you need to change the formula. This is 200, this is 190. So this is just demo because I am not using the original value, so it could be different. 180, and this is 170. I am using very fixed values. 160, and this is 150. So these are the capacitive contributions. So we can draw a graph in origin. Add a column. This is capacitive contribution, this is a current density, so you have to draw between these, and you can get the column like this. So here you can see the capacitive contribution is very high, whereas in case of batteries this capacitive contribution in actual will be low, remember, except at high C rate, but this C rate is not so high. So I am using random values, so that's why it's showing very high capacitive percentage, but for your true test it will be lower, because in case of batteries most of the reaction is dominant by the diffusion reactions, not capacitive reactions. In case of capacitor you will get more capacitive behavior or capacitive contributions. So this is the current density, and here is the capacitive contribution percentage. Okay, so this is the way how you can calculate the capacitive contribution from the specific capacities. Thank you for watching the video.